Dogs!
Let's go! We are live! We are live again! Back at it again! Given an array of integers. कहाँ बैठूँ यार जहाँ पे मेरे को लाइट वाइट सब बढ़िया से आए. वॉशरूम के बाहर बैठूँ क्या? हाय. कहाँ बैठे गाइस जहाँ पे हमको वॉशरूम बाहर भी ना बैठना पड़े. This is the only place I can sit. Right, ठीक है. कहाँ बैठ जाएं हम? Let's see if I can sit here. Oh, perfect. Perfect. Perfect lighting, everything is perfect. Find first and last portion of an element in a sorted array. Given an array of integers sorted in a non-decreasing order, find the starting and ending position of a given target value. I don't understand this question. Let's find out.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve first and last position of an element
I can't hear shit, dude. मैं खाली left सुन पा रहा हूँ. हाँ, ठीक है.
in a sorted array. So we're given an array of numbers and they're in sorted order, in ascending order, and we just want to find a certain value, so a target value that we're looking for, and we want to find the starting and ending index of that value. So in other words, there could be multiple copies of this target value in our input array. And a sorted array. So we're given an array of numbers and they're in sorted order, in ascending order, and we just want to find a certain value, so a target value that we're looking for, and we want to find the starting and ending index of that value. So in other words, there could be multiple copies of this target value in our input array. And if we cannot find the target, then we can just return -1 as the start and ending indices. But so let's look at the first example. So we have a target 8, and you see that there's 2 8s in our example. And the index of them is, so we're starting at 0, this is going to be 3, this is going to be 4. So the starting index is 3, the ending index is 4, so we can return 3, 4. And in another example, we're looking for 6, but we see 6 does not exist in our input array, so we just return -1, -1. Now, this problem is pretty easy and pretty obvious how to solve it, right? Like, the first thing you do is just scan through, keep looking for 8. This is the first 8, then we keep searching, and then we find that this is the last 8 because the next value is 10. So then we can return the indices of these, and that's pretty easy, but that's going to be big O of n time but we want to solve this in log n time, which isn't a problem either because we know there's a log n algorithm called binary search, and that's what we're going to use to solve this problem efficiently. So let's say that this is our input array. We have 6 elements. We want to look for the target, which is 8, right? Let's assume we were just doing a regular binary search. How would we do that? We would have a left and right pointer, right? Initially like this. We'd compute the middle value by taking our left and right and dividing it by 2 gives us the middle. So let's say we put our middle index over here. We look at this value. It's not our target, which is 8. So then we have to update our pointers, right? So we're going to update the middle and we're going to update the left pointer because we know 8 is what we're looking for, but 7 is too small. So we're going to start looking at the values to the right of the array. So we move our left pointer over here. We don't have to consider these values anymore. So now when we recompute the middle, we're going to put it over here, right in between the left and the right. And now we look at the value over here and we see, yes, this is the target 8. This is what we're looking for. So are we done now? That's how regular binary search would work, right? But in this case, we want the leftmost 8 value that occurs and the rightmost, right? We want both of these. So how am I going to implement that? And actually, it's technically possible that this value could also be 8, right? But our algorithm would stop here. And if this value was 8, then we would want this and this, the indexes of these 2 positions, right? So how are we going to handle that? Well, we can modify our binary search algorithm. So let's actually assume that this value is 8. So I'm going to change this to an 8. I'm going to continue my binary search because even though this value is an 8, and let's say we know the indexes of these. So we know this is an 8 and the index is 4, but we know that the rightmost 8 has an index of 5, which is what we actually want. So I'm going to continue the binary search. I'm going to look for the rightmost 8 value in our input array. So what I'm going to do now is update our left pointer. I'm going to shift the left pointer over here in the same position as the right pointer, and I'm going to check this value. Hey, it's 8 again. It's exactly the target we're looking for, and we have no more values to the right of it, so the rightmost index that an 8 occurs at is index 5. So in our result for the rightmost index, we'd put 5. We don't have the left index yet, but that's what we're going to find next. So now what we're going to do is we're going to look for the leftmost index where an 8 occurs, and we can see that this is the position, but we're going to find it using binary search. So we're going to restart our binary search. So in this case, we're going to have to run binary search twice, but we know binary search is log n, so the time complexity is still going to be big O of log n, right? This is next, we're going to compute the target, but shift it to mid -1. And nums, and I'm going to pass in the target that we're looking for, and lastly bias can either be true or the result is right. If left bias is true, that means we're looking for the leftmost index. If it's false, that means we're doing binary search. Left pointer is less than or equal to the right pointer. So the first thing we're going to check is possibly if our target is even bigger than the number we're looking for. And let's first compute that index. So the middle index is going to be left plus right divided by 2. In Python, you need a double slash for integer division. And so let's get that value. So if the target is even bigger than the position we're at, then we have to search to the right position. So we're going to take our left pointer and shift it to middle +1. Otherwise, if the opposite is true, so if the target is too small, it's smaller than the middle pointer, have another one, but I, so we're going to target value that we're looking for. And so what I'm going to do is have another variable called I, so we're going to store the index of it. Initially we're going to have this to be -1, but every time we find the target value, we're going to set I equal to the middle index that we just found it at. Now this by itself, right, if we stop it like this is so far basically just regular binary search, right? But to make the modification to have a bias to this, what I'm going to do here is even if we find the target, what I'm going to do is if left bias is true, that means we're looking for the leftmost value. So even if we find the target value over here, we're going to still update our pointers. So we're going to search to the left, meaning we're going to update our right pointer m-1. Else is if we're right biased, meaning we're searching to the right, then we're going to take our left pointer and set it to be m+1. And this is basically all you need to do to modify the binary search to add this bias condition. So, and let's pass in false since this is going to be right biased, and then we can't find the result in this binary. So this is, isn't it?
What the fuck?
Entire code. Let me
have some water. Guys. What? Bro, that's so retarded. हम देखते हैं भैया कैसा चल रहा है। What the fuck, bro? Pure stink. यार गाइज बहुत बैठने का मन करता है, मन नहीं करता है पढ़ाई करने का, इसलिए स्ट्रीम कर के पढ़ता हूँ।
ओए पराठे खाएगा?
आइला सनी देओल के रेस्टोरेंट में जा रहे हैं क्या?
नहीं, पापा के।
धर्मेंद्र?
ओए पापा को नाम से बुलाता है, देखता नहीं है 2.5 किलो का डोला एंड पा मुकाट दूंगा।
2.5 किलो का सनी देओल का है, आपका 250 ग्राम का है।
तो गाइस अब हम आए हैं बॉलीवुड इंडस्ट्री के ही मैन, मतलब गरम मतलब धर्म पाजी के गरम धर्म रेस्टोरेंट में। पूरा चारों तरफ घुमा के देखोगे ना तो ये रेस्टोरेंट चारों तरफ धर्म जी की मूवीज की थीम के ऊपर बेस्ड है। जैसे वो पानी की टंकी, आपको आइकॉनिक शोले मूवी की आइकॉनिक पानी की टंकी दिख जाएगी। लेकिन हम यहाँ पर उनकी मूवीज गिनवाने नहीं है, हमका खाना चखने आए, तो अंदर चलते हैं और खाना टेस्ट करते हैं। आ जाओ। एक बात बताओगे, यहाँ मेरे पापा की फेवरेट ड्रिंक मिलती है क्या? मिलती है? नहीं। 2 चाय, आलू प्याज पराठा और कढ़ाई पनीर। तो भाई ऑल इन ऑल पूछा जाए टेस्ट के मामले में थोड़ा धर्म जी का रेस्टोरेंट मात खा गया। तो मैं इसको देना चाहूंगा 6.5 आउट ऑफ 10। ओए पराठे खाएगा? बता दे कैसे।
Have you tried this alcoholic tiramisu in Delhi? Although the
इंडिया के इस पार्ट में मामा भांजे की शादी कराई जाती है। 2011 में कर्नाटक की एक 11 साल की बच्ची की जिंदगी हमेशा के लिए बदल गई। एक रात उसके पेरेंट्स ने अचानक उसे उठाया और कहा कि उसकी शादी होने जा रही है। अचानक आई इस खबर को वो समझ पाए उससे पहले उसे एक और झटका दिया गया। उसका दूल्हा था उसका अपना सगा मामा। 11 साल की छोटी उम्र में उसकी शादी उसी के मामा के साथ कराई गई। कर्नाटक के उस छोटे गाँव की लगभग सभी लड़कियों की यही कहानी है। तमिलनाडु, कर्नाटक और साउथ इंडिया की कुछ कम्युनिटीज में मामन कल्याणम की प्रथा एक जमाने में काफी पॉपुलर थी। इसके चलते घर की सबसे बड़ी बेटी की शादी उसके मामा से कराई जाती थी। आज के समय में बड़े शहरों में इसके बारे में शायद ही कभी सुनाई दे, पर कई छोटे गांव और कस्बों में आज भी इस प्रथा को निभाया जाता है। इंडिया के इस पार्ट में मामा भांजे की शादी कराई जाती है। 2011 में कर्नाटक की एक 11 साल की बच्ची की जिंदगी हमेशा के
This is an Android, and this is an iPhone running Android, or at least that's what it looks like, because there is a website called Try Galaxy, and what it does is it turns your iPhone into this Galaxy layout. So it looks like you're using a Galaxy phone on an iPhone, and it's pretty weird. Let me show you how to get this on your iPhone if you're curious to try this out yourself. You're gonna go and open your browser and type in Try Galaxy. So you're gonna go ahead and tap this share button here, and then add it to your home screen. I'm gonna go ahead and add. Now it's on my home screen, so I'm gonna open that up. You won't be able to do everything. So when I open up the camera, I'm not able to take pictures. Instead, it's literally an ad of all the things that you can get with a Galaxy camera. Now, I'm gonna be really frank. I have never heard an iPhone user say, wow, I really wish I knew what the Galaxy interface looked like on my iPhone. But if you are one of those people, you can try this feature out. This is an Android, and this
By combining old movie tricks and modern technology, the filmmakers, with the help of a few fearless individuals,
Hey, how are you?
met the hoverboard challenge head-on. A lot of the hoverboarding that only showed Michael above the knees was achieved by having him ride an ordinary skateboard.
Son of It's been 5 years. I thought I'd remember how to do that.
Paths of plywood were laid over almost every inch of the town square to make it look like Michael was effortlessly gliding over rough terrain. Sometimes a platform dolly was used to give Michael and the other actors an even smoother ride. Director Robert Zemeckis had a special harness designed which allowed the actors to fly from an intricate series of wires supported by an industrial crane.
You know, what we gotta do is we gotta get another crane, and we can hang your phone here.
Yeah, exactly.
And finally,
फिर सैर चला उड़ के छोड़ा
TikTokers love Five Nights at Freddy's. भाई मेरे को पढ़ना पड़ेगा, ये सब बकवास करता रहता हूँ, इतना डिस्ट्रैक्ट।
नशे में जो मैंने ना आना चाहे होश।
सो दोस्तों पहले तो आप ये एक्सरे देखो भाई, कितना शॉकिंग है, मतलब रोंगटे खड़े कर देने वाला है। आप देख सकते हो किस हिसाब से इंजरी हुई है, नीचे का पूरा हिस्सा हिल चुका है। अब आप और शॉक हो जाओगे जब मैं रीजन बताऊंगा कि ये किस वजह से हुआ है। भाई ये एयरबैग्स की वजह से हुआ है। जी हाँ, आपने सही सुना। जो लोग अपने पैरों को डैशबोर्ड पे कुछ इस तरीके से रखते हैं, तो यहाँ पर सेम इसी इंसान ने अपने पैरों को डैशबोर्ड पे रखा था और जो एयरबैग्स है वो डिप्लॉय हो गए और उस वजह से ये इंक्रीज हुई है। भाई एयरबैग की डिप्लॉय होने की जो स्पीड होती है ना, वो 320 किलोमीटर/आवर की होती है। मतलब आप समझ भी नहीं पाओगे और आपके साथ क्या हो जाएगा। तो मेरी आपसे रिक्वेस्ट है, प्लीज भाई डैशबोर्ड पे इस तरीके से पैर ना रखो, और जो भी आपका जान पहचान में ऐसे
Someone went near my BF. This is the face I would make. Someone.
अरे हाँ, इधर ही है कर, मैं बात करता हूँ ना अभी। हाँ, अरे शाम को एक सिद्धांत का प्लान बन रहा है, तू है ना?
होना ना होना तो ऊपर वाले के हक में है। इंसान को बस पहुंचना होता है।
हाँ? पहुंचना है? हाँ, पहुंच जाएगा बोल रहा है।
Guys, I'm showing a Bumble on stream. Fuck this shit. I don't want to. Let's understand this question a little more. Left biases true divided by false. If false, it is true and false. What? Result is right bias. चलो लाइव पता लगता है यार मेरा वाईफाई का चोल हो रहा है यहाँ पे देखो यहाँ तक तो सब ठीक है नहीं समझ आता है गाइस बहुत दिमाग हमारा खराब हो चुका है इफ
Let's get our left and right pointers. Left is going to be 0, right is going to be the length of the input minus 1, and we're going to keep going while going to be the left, the third, or the right. Last, what I'm going to do is have another variable called I, so we're going to store the index of it. Initially, we're going to have this to be -1, but every time we find the target value, we're going to set I equal to the middle index that we just found it at. Now, this by itself, right, if we stop it like this is so far basically just regular binary search, right? But to make the modification to have a bias to this, what I'm going to do here is even if we find the target, what I'm going to do is if left bias is true, that means we're looking for the leftmost value. So even if we find the target value over here, we're going to still update our pointers. So we're going to search to the left, meaning we're going to update our right pointer m-1. Else is if we're right biased, meaning we're searching to the right, then we're going to take our left pointer and set it to be m+1. And this is basically all you need to do to modify the binary search to add this bias condition to it. So now our binary search function is complete. Well, the only thing we really have to do now is call this function twice to get our left and right index and then return that.
Oh, the fuck he's writing left bias. What the fuck is left bias?
We just found it at. Now this by itself, right, if we stop it like this is so
ठीक है अगर राइट में है तो हम लोग राइट में चले जाएंगे लेफ्ट में है तो हम लोग लेफ्ट में चले जाएंगे ये ठीक है इतना समझा.
What I'm going to do is have another variable called I, so we're going to store the index of it. Initially we're going to have this to be -1, but every time we find the target value, we're going to set I equal to the middle index that we just found it at. Now this by itself, right, if we stop it like this is so far basically just regular binary search, right? But to make the modification to have a bias to this, what I'm going to do here is even if we find the target, what I'm going to do is if left bias is true, that means we're looking for the leftmost value. So even if we find the target value over here, we're going to still update our pointers. So we're going to search to the left, meaning we're going to update our right pointer m-1. Else is if we're right biased, meaning we're searching to the right, then we're going to take our left pointer and set it to be m+1. And this is basically all you need to do to modify the binary search to add this bias condition to it. So now our binary search function is complete. Well, the only thing we really have to do now is call this function twice to get our left and right index and then return that. So let's get left by calling our binary search function, pass in nums, the target value, and then this is going to be, and by default, if we can't find the result in this binary function, it's going to return -1, which is exactly what they wanted us to do. So this is actually the entire code. Let me just prove to you that it works and prove to myself that I don't have any bugs in it.
Let's see guys, I don't know how to do this. मुझे समझा तो नहीं है guys, समझा दे अच्छे से तो बढ़िया बात है, नहीं तो कोई बात नहीं। गर्मी लग रही है तो इधर बैठ के कर रहा हूँ। क्या हो गया? 2 ट्रैक करना है भाई, चलो सही है भाई। क्या है आज संडे? हाँ आज क्या है भैया? मंडे है आज। अच्छा वेरी बैड हो गया जी, वेरी बैड।
भाई तूने इजराइल की न्यूज़ पढ़ ली?
हाँ
इजराइल की न्यूज़ पढ़ ली?
ना।
इजराइल हैज डिक्लेयर्ड अ स्टेट ऑफ वॉर विद पैलेस्टीन। फिर फुल ब्लोन वॉर चल रहा है। हमास ने 4 साइड से अटैक कर दिया इजराइल पे एक रात के अंदर, लैंड सी एयर हर जगह से। 1100 लोग मर चुके हैं।
1100 लोग मर चुके हैं, मतलब सिविलियंस हैं वो या फिर
सिविलियंस और सोल्जर्स को मिला। और हमास ने अटैक कर दिया। हमास है टेररिस्ट ग्रुप पैलेस्टीन का, जो पैलेस्टीन की आर्मी बोलते हैं अपेरेंटली। ये लोग घुस गए इसमें भाई किसी म्यूज़िक फेस्टिवल में। इजराइल में कोई म्यूज़िक फेस्टिवल चल रहा था, उस पर V2 रॉकेट्स लॉन्च कर दिए उस म्यूज़िक फेस्टिवल में 300 लोग मार दिए और बाकी कुछ 150-200 वहाँ से वो कर दिए हॉस्टेजेस बना के ले गए वापस पैलेस्टीन। ओह भाई मैं फोटोज देखी भाई बॉडीज ऐसी पड़ी हुई हैं आधी अधूरी बॉडीज पड़ी हुई हैं। शिट फक्ड अप भाई इतना फक्ड अप है।
Can't understand this shit. I can't do this. While it is smaller than R, again, how? Otherwise,
Okay, let's solve leetcode 33 search and rotated sorted array. So we're basically given an array that was originally sorted like this one, but then it became rotated like this one. And by rotated, they mean that they took a certain pivot or index of the array, like right over here, and then they cut it in half and then swapped the portions, right? So you can basically think of this right-hand portion being swapped over to the left side over here, right? That's what happened, as you can see here. Right, these two halves were put in the opposite position. And we're also given a target value, in this example, target 0, and we want to check if our array contains this value. If it does, we return the index. If it doesn't, we return -1. The most straightforward way to approach this problem is literally just check every single value. Is this our target? Is this our target? And eventually we'd get here, this is our target. And then we return the index 4. Now this is just too trivial of a solution, right? The time complexity isn't bad, it's O of n, but can we do better? In this problem, they literally tell us to find a solution that's O of log n, so obviously we can. And basically, anytime you're looking for a solution that's log n or better than linear, almost every time you're going to be looking for a binary search type solution. So since this array was originally rotated, can we use that to our advantage to potentially find a binary search type solution for this problem? Let's try to analyze it and see what we can find. So given that the original array was sorted, if we wanted to represent that as a graph, we would basically have a continuously increasing line. It might not necessarily be linear, but it would always be increasing, right? And then we took some pivot, like over here, and then swapped these halves around, right? So let's draw what that would look like. So let's say the left side was exclusively greater than the right side, because that's what it means by rotating the array, right? So I think this is a pretty good way to visualize the problem to kind of understand what it would look like. And you can use this to your advantage to find potential patterns that can help us find a binary search solution. So with a problem like this, you really have to break it down into discrete cases and then use those cases to form a solution. So the most obvious thing is that there are two portions of the array, right? There's a left portion and a right portion. Both independently are sorted, right? So it's like we have two halves that are sorted. And so we know that a binary search usually has 3 pointers, a left pointer, a middle pointer, and a right pointer. The left is always going to be less than or equal to the right. This is just something you kind of know from binary search. So let's say our middle value was 6 at some point, right? This means that we're in the left sorted portion of the array. So can we use that to our advantage? So let's say our target was greater than 6. In that case, we know for sure, since we're in the left sorted portion of the array, none of these values are greater than 6. So we can basically say these are eliminated. Let's run binary search on this portion now, right? So that's pretty easy. If we know that we're in the left sorted portion and our target is greater than the middle, this is what we can do. What if our target is less than the middle value? So what if our target was less than 6? Well, these two numbers are less than 6, and these 3 numbers are less than 6. So how do we know which way to go? Do we go left or do we go right? Because we can't go both directions in a binary search. The key is to see that in our left sorted portion, the smallest value is right here, right? Or on our graph, it's right here. So if our target is even smaller than this left value, 4, in that case, we know that we don't have to search 4, we don't have to search 5, we don't have to search 6. We can run binary search over here. But if our value is greater than or equal to 4, then that means we're going to run binary search on these two values, right? It's less than 6, but it's greater than or equal to 4. So we can run binary search on these two values. We can eliminate all of these from consideration. So all of that is if we were in the left sorted portion of the array, right? Now what happens if we're in the right sorted portion of the array? Let's say our middle was 1. And let's say we knew somehow that we were in the right sorted portion of the array. What if our target was less than 1? Well, then we know we have to search the left. The only value less than 1 is right here. So we're going to search the left portion of this array. We're not going to look at 1. We're not going to look at 2 anymore. Any value to the right of 1 is greater than 1, so we don't have to look at them. We're just going to run binary search on these elements. We don't necessarily have to know where the pivot even is. We just know we have to go left. But what if our target was greater than 1? Well, then our solution could possibly be 2. It could also be any of these 4 values. So then where do we go? Again, we can use this rightmost value, or the edge basically of our array, to our advantage. So if our target is greater than 1 and it's also greater than 2, that means we can again search this left portion. We can eliminate these 2 from consideration. But what if the opposite is true? What if our target is greater than 1, but it's less than or equal to 2? In that case, we only have to run binary search on the right portion of 1, every value to the right of 1, meaning we can eliminate all of these from consideration. So that was a lot of discrete cases, and it might be confusing. I think it'll be a little easier to understand what's going on before you even write a single line of code. And knowing what we just learned, let's just go through this example of the target equal to 0 and given this input array. So initially, our left pointer would be here, our right pointer would be here, our middle would be here. So how do we even know if we're in the left sorted portion or the right sorted portion? Well, the way I check is just if our middle value is greater than or equal to our left, the actual value at that index, if this is true, then that means our middle value belongs to the left sorted portion. If this wasn't true, that means our middle value is in the right sorted portion, and we would write our if statements accordingly. But knowing that we are in this left sorted portion, right, let's run through it. So our target is 0. Then new middle is going to be here. Or we could be... Let's run through it. So our target is 0. That means our target is less than 7. So our target is less than 7. That means we could be looking here, or we could be looking here. So let's compare it to 4 now. Is our target less than the leftmost value? Well, 0 is less than 4. Okay, so that means we're all good. We just have to search every value to the right of our middle value. So cross out here, the right sorted, middle, and if we don't have iteration, to search, first thing you do is in right is going to be while this. And like I mentioned before, we can check that. The else can greater than the middle value. So think start right this and them up over this. You search the, and just as it will exit the loop and we'll return -1.